Okay, so today we've got a unit circle exploration, and we have some toys. So we're opening up our bag of unit circle pieces, and it says to find the quadrant ring and place it in the coordinate plane. So there is a frame here for us. We have 4 rings and lots of different pieces. We're going to grab the quadrant ring. All right, so to orient this correctly, it says quadrant 1. I believe this is quadrant 1, so we're going to put it in this spot, and we're going to place it in there. It looks like the lines aren't quite lining up, but pretty close. And it says, okay, what do the parentheses in each quadrant name indicate? Well, if we have a positive here, that means that the x-coordinate is positive and the y-coordinate is also positive in quadrant 1. Second quadrant, we went left, so x is negative, y is still positive, and so forth. So next find the degree ring and place it in the coordinate plane. Okay, so we've got a degree ring that appears to be this one. I'm going to place that in the coordinate plane as well. And I guess it makes sense that 0 degrees would be right here. And yeah, it looks like it goes to the positive x-axis for 0 degrees. So from 0 degrees, the measures get larger in we're going to the left, so that would be a counterclockwise direction. There are 2 basic types of triangles in your unit circle. With your unit circle and your unit circle set, can you identify them? All right, so we've got some triangles up here. These look like they're the same size, different orientation, but the same size. And these look like they're the same size as well, but again, different orientations. So yeah, we've got 2 different kinds of triangles. These have right angles. Well, they all have right angles, but these have 2 equal sides, so these are isosceles right triangles, 45-degree angles, and these are looks like half of equilateral triangles, so 60, 60, 60 split in half, so 30, 60, 90s. Okay, so place the small arc on each triangle, or the small arc on each triangle indicates the angle that should be placed at the origin. Okay, right there. So practice placing each type of triangle in each quadrant. Okay, so let's stake this triangle. We're going to put it in this quadrant. Okay, looks like it fits. If I want to put it in this quadrant, though, that seems weird. So let's try this one. Okay, that one works there. And then can I put this one down here? That seems weird. So, okay, that makes sense. And then finally, like that, maybe? Okay, so it looks like that works. Okay, let's try it with the other ones. Now we're grabbing this one. Looks like it doesn't want to go here very well. It looks awkward, but it could fit here. And this one could go here. This one could go here. This one could go here. So those work. Looks like the right angles are always along this x-axis. If I put this here, it seems weird. So yeah, this one looks like it can go there. That means this one could go there. We could go here or here with this one. Okay, it looks like we can get them kind of all in the same. Okay, that works. Okay, so yeah, it looks like the right angle always looks like it's gonna go here if this little angle that's noted is at the vertex or at the origin. Okay, so compare the triangles and how are they similar? Well, the two 45-degree triangles are similar, just different orientations, and the 30, 60, 90, same thing. But it looks like we have different orientations based on whether we need the big angle to be at the origin or the small one, so the 60-degree or the 30-degree. Okay, hypothesizing here. Okay, so then it says, why are each of these circles called unit circles? Unit circles. Why would they all be unit circles? Well, this one, it's got some pies in it. Well, this looks like it has ones at the quadrants. Oh, the radius is 1. Radius, yeah, the radius of a circle is 1, so I guess that's why they call it a unit circle. Okay. And then place 2 isosceles right triangles in your unit circles. In the circle in the first and second quadrant, remember that the arc shows where it should be, that the angle should be at the origin. Okay, so these are our 2 isosceles right triangles, that one and this one. And the arc has to go to the origin. Okay, so we did that. And based on the measurements of the triangles in quadrant 1, what should the tangent of 45 be? This is a 45-degree angle, and tangent is TOA of SOHCAHTOA, so opposite over adjacent. Square root of 2 over 2 over square root of 2 over 2 is 1, so the tangent should be 1. Now, recalling the parentheses in the quadrant ring, what should the tangent of 135 degrees be? Okay, so here's 135 degrees, so the tangent of 135 would be opposite over adjacent, square root of 2 over 2, square root of 2 over 2, so that would be a 1, but in that quadrant, quadrant 2, I am positive vertically but negative horizontally, so this would be a negative square root of 2 over 2, so negative 1. Okay, so let's put them into quadrants 3 and 4. So quadrant 3, yep, that one's going to go in quadrant 4. This will go in quadrant 3. And because we're in quadrant 3, and I've got a negative and a negative, negative square root of 2 over 2 divided by negative square root of 2 over 2 would be a positive. So the tangent of 225 degrees could be a positive 1. And then at 315, I am right and down, so my adjacent is positive, but my opposite is negative, so a negative 1 for tangent of 315 degrees. Okay, so it says take out your calculator and verify that it's in degree mode. All right, so degree mode, yep, we're there. And then find the tangent of 45. Okay, tangent 45 degrees was 1. Tangent of 135 is negative 1, second quadrant. We thought the third quadrant would be positive. Yes, and then tangent of 315, negative 1. Yes, so it works. Okay, so let's figure out the sine of 45 degrees. So sine of 45 degrees means I'm in this first quadrant. My hypotenuse is going to the 45-degree mark. My sine is the opposite over hypotenuse, so opposite is square root of 2 over 2, hypotenuse is 1, okay. That's why we're using a unit circle maybe, so we can just look at this and see that the opposite, the y value, is square root of 2 over 2, so sine of square root of 45 should be square root of 2 over 2. But second quadrant, 135, we're left and up. And so this would be a negative square root of 2 over 2, but this would be a positive square root of 2 over 2. And sine is opposite over hypotenuse, so positive square root of 2 over 2 over 1. I think the sine is going to be positive square root of 2 over 2 here. All right, let's try third and fourth quadrants. (225), we are now opposite. The y is now negative, but the x is also negative. So opposite over hypotenuse, negative square root of 2 over 2 over positive 1. And then in the fourth quadrant at 315, the sign would be negative because the opposite's negative and the hypotenuse is positive, so negative square root of 2 over 2. All right, so those decimal equivalents, do they match up? Okay, so square root of 2 divided by 2 is 0.707. Okay, so 0.707. Now if we do the sine of 45, it is the square root of 2 over 2. The sine of 135 is also a square root of 2 over 2, but the sine of 225 should be negative. It is. And the sine of 315 also negative. Okay. So cosine of 45, well, 45, 45, 90, cosine of 45 should be same as the sine of 45. It should be square root of 2 over 2 over 1, adjacent over hypotenuse for cosine. And then in this quadrant, because the x is negative and the y is positive, my adjacent's negative, so negative square root of 2 over 2 over 1. But in this quadrant, again, the x is negative, so negative square root of 2 over 2, the adjacent's negative over 1. And then this quadrant, the x is positive. And so my adjacent's positive, my hypotenuse is positive, so cosine of 315 should be a positive square root of 2 over 2. Okay. So now that we move these to the side, examine the remaining. These we said were the special right triangles that are 30, 60, 90s. Okay. And so let's put a 30-degree angle. This one's got a smaller angle here. That's the larger one, so a 30-degree angle at the origin. And the sine of 30, opposite is a half. Hypotenuse is 1, so 1/2 over 1, the y value over the r, which is 1. So sine of 30 should be 1/2. Cosine of 30, adjacent over hypotenuse, should be square root of 3 over 2 over 1. So square root of 3 over 2, and the tangent of 30, opposite over adjacent, oh, that's a lot. 1/2 divided by the square root of 3 over 2. So 1/2 divided by square root of 3 over 2. Means I'm going to take 2 over the square root of 3 and multiply the numerator and denominator by that, which is 1. That eliminates that. The 2's disappear, and I've got 1 over the square root of 3, which we rationalize as square root of 3 over 3. Okay, tangent of 30 is the square root of 3 over 3. Okay, so place that 30-degree angle arc in quadrant 2. If I try it with this one, it seems weird. It doesn't match up right, so we gotta go grab a 30-degree angle down here and put it in quadrant 2. And we're at a 150-degree angle. The sine of 150 is going to be opposite over hypotenuse 1/2 again, and this is positive vertically. The y is positive, so sine is positive again in that quadrant. So sine of 150 is 1/2. Cosine of 150 is that negative square root of 3 over 2 over 1. And the tangent of 150 is going to be a positive 1/2 over a square root of 3 over 2. So once again, a negative square root of 3 over 3. What's a 30-degree angle in quadrant 3? Quadrant 3 is down here. 30-degree angle in quadrant 3 means I need this piece. And that's a 210-degree angle. Oh, that makes sense because 180 and 30 gives me 210. What will the sine, cosine, and tangent of this angle be? Well, sine is going to be negative because the y is negative, so negative 1/2. Cosine is going to be negative because the x is negative, so negative square root of 3 over 2 over 1. And tangent's going to be a negative over a negative, so positive square root of 3 over 3. And what about the 30 in quadrant 4? I gotta grab this one now. 30 degrees in quadrant 4. Sine should be negative because the y is negative. So negative 1/2. Cosine will be positive because the x is positive, so square root of 3 over 2. And tangent should be negative because opposite over adjacent is going to be a negative over a positive, so negative square root of 3 over 3. Okay, not too bad. So place the 60 there, find the sine, cosine, and tangent of all the 60-degree angles. Okay, that means you're just using a different kind of triangle. So slightly different anyway, orientation's different. And the sine of 60 is square root of 3 over 2 over 1. Cosine is adjacent over hypotenuse 1/2, and tangent is square root of 3 over 2 over 1/2. So multiplying by 2 over 1, or multiplying by 1, so we're okay. That disappears, and we just get a square root of 3, okay? So tangent of 60 is the square root of 3. Just check it out here, tangent 60, square root of 3, oops, square root of 3, and that was the same thing as the tangent of 60. Yes, we're good. Okay. So, table of values. Looks like this core value, sine of 30, 45, and 60 plays out. When we know those, we know the 120s, 135s, 150s, 210s, and so forth because they're just sign changes. Ooh, but the tangent of 405. 405, what the heck is that? Well, we're at 330, and this is 30-degree gap, right? So that would be 360. I wonder if we could keep going. So 360, 405 minus 360, Claire, sorry. 405 minus 360 is 45, so I bet it would be the same as the tangent of 45. So 1, let's verify tangent 405, 1, repeating patterns. Okay, sine of 510, 510 minus 360 is a 150, sine of 150, that was a 30-degree angle, and the sine of 30 was a half. And the opposite is positive, and the hypotenuse is always positive, so yeah, 1/2. So sine of 510, 1/2, okay. The angle gets bigger on the unit circle as you move counterclockwise. What happens as you move clockwise? Ooh, well, if we were going from 90 clockwise, it looks like they're going smaller.